fine. It says, oh, there it says live now. Okay. Daniel said that he will be ready within 5 to 10 minutes. So we could just go ahead and get started and he can hop on if you guys want. Otherwise, we can wait. It doesn't matter to me.
No, let's just get going.
Okay. We can start discussing whatever. Do you guys want to start with a prayer or?
Sure.
Okay.
Yeah, we can do that.
I'll say it this time if that's okay with you guys.
That is.
That works.
All right. Our dear, kind, and gracious Heavenly Father, we're so grateful for this day. We're grateful for the opportunity we have to be able to discuss and learn more about this earth that you have provided us. Heavenly Father, we ask you, please help us to be able to accomplish all that is set before us and that we may be able to continue to learn and grow and support each other through this course. And we say these things in the name of Jesus Christ. Amen.
Amen.
All right.
So let's look at this.
So one thing from the reading that I kind of understand but kind of don't are those three types of what is it? I don't even remember now. Three types of something like the transform. One started with a C and one started with a D. And so like the plates either like break apart, right? And
isn't it like convergent?
Material is destroyed, I guess, or they like start to build on each other. Is that correct?
Yeah, the convergent and divergent plates.
Right.
So the convergent boundaries are the ones that are coming together, and then one will go underneath. Mm-hmm. And then the divergent are the ones that pull apart, and then the transform boundaries are the ones that slide against each other.
Okay.
And so
you were talking about satellite images. Is that one way because of those changes? Is that one thing that you would see from satellite images?
Yeah, we could probably be able to see those, like the different rifts. Like they talked about how the Red Sea was made that way. Mm-hmm. That over time the Saudi Arabia, that peninsula, broke off from Africa and came apart. And so that's sort of what they're talking about was happening with the Baja Peninsula as well, and up along, I believe it's the San Andreas Fault. And so you could map that as it's starting to move over time. You can use satellite imaging to do that, as well as using probably GPS towers. You could even probably do something with mountain elevations, because in India and the Himalayas running into the Asian and the Indian plate coming together, you could probably measure the height of those if that changes anything, because I know that it also weathers, but
right,
that could be one to see if it's growing at all. But and
I wonder if you could put something like between, like on two sides of the plates, to where almost like a house or something, I guess, to where like you can notice it.
They did like there's ones with drilling on the sea floor to be able to tell for some of those divergent boundaries and for the plate movement. Mm-hmm. That could be one to help with knowing that the older the crust is on the sea floors, as it gets further and further away from those rifts, that you could be able to somehow map the thickness of it, because as it gets more dense, it gets thicker. And so we could compare that to the ones by the rift, the younger ones to the older ones, if you're able to by and build enough a big enough drill.
Mm-hmm.
So satellite drill.
Yeah, so I don't know about
is there anything like surface-wise that you could do? Like putting something on the surface between where the two plates are to really like measure if it's coming together or if it's separating or if it's moving against each other.
Okay.
Would that be what kind of object are you talking about? Like it measures I'm not sure.
I don't, like almost having like not like a tower, but something that almost, how do I explain it? It's like having a tower on one side and a tower on the other that kind of are coming together to the point where you can measure like either yearly or monthly if it is moving like even centimeters at a time.
Okay.
Oh, okay. Yeah, because I know, like in the reading, it showed that picture of the San Andreas Fault and how you could kind of tell that how it's a transform boundary and how it's been stretching along, how they had that trench and how it just spread across. And so you could do that along that one to be able to visualize, see, here's where like they started out together and measure then how far apart those markers are.
Yeah.
Right.
Because that's the one thing that would be kind of cool to see between each plate, how much it actually moves in like a year.
Exactly, because it only moves about an inch a year. I think 6 inches in the Pacific is what I read. But over the space of like 100 million or 180 million years, it's moving at least, yeah, it's moving over 2,000 miles.
Wow.
And so
something that I read, so what was our Geo journal? I kind of was reading about the Haiti earthquake. And so whenever plates are moving, it's not always like this smooth movement, right? Like they kind of like build tension. And so that whenever that tension breaks is like earthquakes and stuff.
Mm-hmm.
And so it was saying that those plates near Haiti move like 25 centimeters, or I don't remember exactly what the measurements were. But the last earthquake in that area was over 200 years ago. And so that's the only thing with measuring in that way is that some of those places, some of where, plates meet, it's not like so much of just like an easy drift and stuff.
Yeah.
But build tension. And so some of those you can't measure in all places, but some places like you're talking about are kind of a constant thing. That's one thing that I thought was interesting too, is that, that it's not ever like not always a smooth. It builds a lot of tension sometimes too.
Yeah. So that would be interesting, like with earthquakes and stuff, the towers, like you wouldn't see much progress them moving, and then once the earthquake happens and they break free of each other, then you get that huge shift, like that 25 centimeters where the plates would move a foot.
Mm-hmm.
And I wonder if certain plates in certain areas, what would make it like Arctic, if like the cold water has an effect on it versus the warm water, like if the magnetic field has anything to do with the North and South Pole. Like I wonder if there's anything more Because we just think, okay, they're coming together, they're spreading apart, they're rubbing against each other, but is there anything that actually contributes to a certain section moving at a certain rate, or anything that's more specific than it's just nature and it just moves whenever?
Right.
Yeah. So I don't know, like, how they'd be able to do that. Like, because if you did it, you could do it on the Pacific side, and then that rift over there, and then also the Mid-Atlantic rift to see what's the big difference between both of them, because the Pacific one moves faster than the Mid-Atlantic.
Mm-hmm. That's a good idea. That makes sense.
So just looking at those characteristics of each one to see what's so special about the Pacific that makes it move faster than the Atlantic.
Mm-hmm.
Okay.
And I guess you could see which side, whether it's on the north, south, east, or west, which side gets pushed further, whether the other side gets pulled away, and if it does move back again and things like that, and kind of monitoring, like, is it just staying within like a certain parameter and it way and comes together and then rubs up and down, and just kind of the variations of what it does, or if it's like stationary and the mantle is liquid, then does the plates actually rotate around the Earth?
Yeah.
Or is it just kind of in a stationary kind of certain area?
In the reading, it did say that the plates are constantly changing because they do like move against each other. And so that's an interesting question.
But in those like 200, but in like that 200 million years, I wonder, like, changed, like, to see somehow like the progression of the way that it's been made into the way it is now.
Right.
Like, that'd be really cool to somehow see.
Mm-hmm. That kind of ties into like that idea of Pangea. Is that how you say it?
Of what?
Yeah, Pangea.
Pangea.
Yeah.
That, I mean, they didn't just like float apart. Like, it's not just like that they just somehow separated, you know. But if they were in one, they didn't just somehow separate. So these plates have
But that's also interesting, because when you think of Pangea, you think of just like the continents, but then you got to think we're attached to everything that's underneath us somehow, and so how did everything break apart and then come together to where things are still moving, but everything...
Right, exactly. That's what I meant by, you know, like, it didn't just float apart, you know, like, it's not like there's this bit of land that's floating on water because it's surrounded by water, so it didn't just float apart. But yeah, that's a really interesting thing to imagine, because that kind of tied into how your previous topic in question about, like, are they more stationary or do they move around? And if you think about Pangea, I mean, I don't know.
You know, yeah, because that wouldn't make any sense, because I don't think everything was somehow made somewhat like a volcano, where everything just moved upward from the rock. So I don't know if Heavenly Father just placed the regions or the continents where they are. It just makes sense. It's hard to think of Pangea, because if everything were to separate and crack, how are these tectonic plates then everything was together at once?
Mm-hmm.
Well, one of the articles that I put up for this last GeoJournal is talking about Venus and about how they're theorizing that the immense heat on the crust is starting to loosen up the things underneath Venus's crust, and it's the start of plate tectonics, where it's starting to get that softer layer underneath the top layer, and soon they'll start breaking apart these different lava fields into different pieces of crust on Venus. And so they're thinking that this is going to be the the start of it. And so if we did have Pangea here, there must have been something like that, something that finally was able to heat up the asthenosphere enough to allow the continents to start the plates to start drifting.
So. Hey, Daniel. Daniel just joined us, guys.
Hey, Audrey.
Hey, what's happening, man?
Hi.
Going good.
Going good. We've just been kind of throwing out some ideas, talking about what we learned from the reading a little bit, trying to understand a little better so that we could better determine some of like the experiments that we would like to do to better understand these things. So whatever you've got going on in your head, you're ready to listen.
What was the topic again? Sorry. I'm way like single-minded right now.
Okay. So this week's group activity, come up with a series of experiments you would like to conduct, unlimited in time, to test the theory of plate tectonics.
To test the theory of what?
Test the theory of plate tectonics.
Right.
Anything you thought of, or any questions you have? We've like kind of just talked about the reading a little bit and gone from there just with ideas of what we have thought. Like just now we were talking about Pangea and what we thought of that. And that Micah had said something about his idea of, do these plates, are they stationary or do they kind of move around? Is that right, Micah? Is that what?
Yeah, so it's like how the way that we see them, like on a map, they're in certain locations and they fit together almost like a puzzle, but does it move slowly like around the Earth? Like obviously the Earth rotates, but do the plates not heading anywhere? We're not north or anymore south, but do the actual plates in a sphere? Because if the mantle's mostly liquid, then we're almost floating on it. So then if the Earth turns, then we would turn with it, or I don't know. Or do the plates just kind of stay in a certain boundary? If they do move, like, do they only go like 5 meters north, 3 meters east, 10 meters west? Like, to really find out, to see if like really they only stay in like a certain geographical area. Because we're not moving any further north to become colder like Antarctica, and we're not moving anywhere near close to the equator to be more warm. So it's like, you would think it only just stays in one spot, and then it just fills wherever.
Yeah. Well, so I guess it depends on what exactly, when it says plate tectonics, what is it actually talking about? As far as I understood from reading, like the plates are only, what is it called, the lithosphere, right? And so so that would mean like the outer shell, the plates are secluded to the outer shell, not necessarily the rest of the planet. I don't know if that makes sense. Right. That's kind of the impression I got.
Yeah.
But I do remember from the reading that it talked about how, like, essentially the Earth was rotating around its core, if that makes sense. Like what was it? That the lower mantle is separated from the asthenosphere. I don't know if I have the right terms.
Okay.
But so our plate, as far as we understand, our plate tectonics, is that just the outer shell? Are we just talking about the outer shell of the planet, the lithosphere, I guess?
I think what we're talking about is it's the entire system, the lithosphere and the asthenosphere, and the movement of the plates. Basically, the theory that there are plates all around and that they are moving, and that they're moving with that convects up through the mantle into the asthenosphere. that warm kind of liquid that talks about that softer rock in the asthenosphere that moves up, and then as it moves up closer to the lithosphere, it cools, and then it goes back down to the bottom. Cycle happening all over the globe is what's pushing or pulling the plates, which causes them to move boundaries. And so at the divergent boundaries, that's as they're being pushed apart there, and that there's new seafloor or new parts of the lithosphere that are being created, and then they're being pushed under at the convergent boundaries, if that makes sense. So it's kind of that theory of proving that they're actually moving, and that there are plates. So like one kind of a redneck sort of experiment that we could do, since we have no budget, since we have a unlimited budget, is dig 2 giant holes across a plate boundary, and then stick giant posts in there and run a metal cable from between them, and then just observe how long till you see the posts, they'll start to bend. If it's on a divergent boundary, the posts, they'll start to bend out, or the cord, that a metal cable, will become tight and then eventually even break if the posts don't break first. And so that's one kind of a very simple experiment that you could run to be able to show that the plates are moving.
Yeah, that makes sense.
Or if it's on a convergent boundary, you can start seeing them come together and more slack, and the posts becoming together. So that's kind of a little like kind of redneck sort of way, where you don't have to use GPSs, and since it'll take a lot of time, it's something easier to visually see.
Yeah. I don't know. One of the ideas I had about experimenting with it is I was wondering if there might be a way to recreate what the plates do on a smaller scale, and being able to observe it at like a faster rate. So like, is there a way that you could basically recreate the planet, putting every kind of variable into it? You know, like people have been able to kind of recreate some of the processes of the sun at a miniature scale. Would there be a way to do that with the planet itself? And in the reading, there were some different ideas about how plates happen. Like maybe I think one of them was maybe the meteorites had been hitting the Earth so much that it started creating this like tectonic process. If I remember right. But yeah, like, would there be a way to recreate that so that you could see it on a smaller scale?
I wouldn't see why, because if limited amount of money and time, you can get the people that know how to do it, and then you just say, throw a meteor at this thing, see what it does, and if it doesn't work, then change it and do another thing. So that'd be kind of cool to recreate the planet on the planet, and then kind of test the theories that other people have come up with, and even with those, maybe combine them and do it all at one time and see what would have possibly happened.
Yeah, because I mean, I guess I feel like the idea is simpler than it really seems, because what you're trying to do is you're trying to recreate, not necessarily like the outer surface of the planet, you know, like the water and the grass and the trees and stuff. You're trying to recreate the different spheres in the planet, you know. So you have the lithosphere, you have the asthenosphere, you have the core, and the different components of each of those, and the different metals. And not only would he be testing to see how the plates and different the different sections of the Earth reacts, but you're also trying to recreate the elements of the Earth as well. I don't know if that makes sense.
Yeah.
But then, well, once you recreate all of that, supposedly the supposedly there's more to the Earth than supposedly there's more to the plates than it being a natural process of the Earth. Like what? Then you would have to see what caused the plates to become a part of the Earth. I don't know. Does that make sense?
Yeah, it does to me. Like if there's any like extenuating things that are like that, whatever would be normal for the Earth, like the meteors aren't something that's normal. So anything that wouldn't be a natural function of the Earth, or if something outside of that affected the Earth to where that part of it became a natural process.
Yeah.
Right.
Yeah, because according to the reading, from what I remember, they consider that plate tectonics weren't really they weren't really a natural process of the Earth, and it's something that kind of happened. I guess it's a natural process, but it's something that didn't come into action until much later through, meteorites and stuff like that. So I guess the experiment would be to see how do we get to the point in order to see what puts the plate tectonics into motion. So you would recreate the planet, then you're going to try all these experiments like simulate asteroids hitting it and simulating whatever else, maybe trying to simulate volcanoes and mountains and stuff like that in order to find out, okay, what is going to cause the plate tectonics to come into action.
Yeah. So I wonder if the meteorites would be like throwing like a pebble at like a piece of glass and it's spidering and it only be cracking in certain areas and like bigger and then smaller pieces, and then like what caused it to actually break and then
yeah
happens.
Yeah, that's a good idea.
That'd be pretty cool if somebody could actually build it. That would be dope.
Mm-hmm.
It'd almost be like the moon where it's like close, but it's not close.
Yeah. Well, and you would also be trying to see, like, is plate tectonics, like, whether or not, because I don't know if you could really say, like, for certain, like, is this something that happened over time because of different variables, or is it something that is actually a natural process of the Earth? And actually, so I had this thought the other day about plate tectonics, something that might be a simpler experiment that, I mean, you'd still need like a lot of time and money, but something that might be a little bit simpler is like, what if we went to other planets, like we went to Mars and we looked at it like, does Mars have the same functions? Like, if we're looking at the planets, do they have plate tectonics? There's something going on beneath the surface that we can't see. And assuming that one of the purposes of plate tectonics is to essentially like recycle and rejuvenate the Earth, does Mars and these other planets have the exact same function?
Did you mention something about a different? You?
What was that?
Ted, I don't know if he mentioned that. I feel like Ted mentioned that earlier, something about that, but I don't remember exactly.
Yeah. The article that I put up for my GeoJournal is talking about researchers looking at old photos of Venus and how it started to look like there were plate tectonics, plates starting to form there. And they were kind of guessing about kind of what was starting it. And they believe, since I think they said the surface of Venus is at 406 degrees Celsius. And they're thinking those higher heats started to loosen up under the stuff underneath Venus's crust, enough to make it to jiggle just enough to start this little bit of movement, the same as what we theorize about the plate tectonics here. And so those images that they're studying were back from in the 90s. And so they're kind of guessing that this might be the beginning of plate tectonics. And so that's one place where they could look at to study to see what is going on with the beginning of it. And it might be able to tell us what happened here as well.
Because I wonder, like, how far obviously it's really hot in the mantle and the core, but to what extent does it go out to where it cools? But then if it's needing new material for it to expand, like divergent boundaries when the part of the crust goes inwards towards the core and then it heats up, I wonder if it, because obviously magma is in volcanoes and stuff, I wonder if it pushes out and it actually expands, because obviously the further away it cools down, but you can only you either have to expand the earth either has to expand to a certain extent, because it can't just recycle so much of its crust and then not create anything else. But how far down does it have to go for it to recycle, then to push it back out to create, to separate the boundaries?
Yeah, because I know they talk about in the reading a lot of the convergent boundaries, because they're talking about the Cascade mountain ranges and the volcanoes there, about how as it goes under, so you see where all those volcanoes are, that's about how far it goes before it starts melting, and then that magma is starting to push up. So that's about where that melting point would be. And it talks about how the wet plates coming in from the ocean, they have a lower melting temperature than the plates would be if it were dry. I don't know if that helped answer your question at all.
But that's also interesting that it has a lower melting point, because isn't it cooler towards the ocean floor rather than on the surface?
Yeah.
Rather than when it's dry, rather than when it's cold?
Well, I guess it depends on how far the plates are going to extend, because the farther up they go into the air, the cooler it's going to get. And, different parts of the earth are a lot colder. I don't really know exactly how cold it gets, 10 miles beneath, 10 miles deep in the ocean, or how, I guess it's not 10 miles. It's probably more like a mile.
Yeah. So I guess that could be one of the experiments that we run, is just drilling down close to where those volcanoes are, drill down far enough to see if we could get a temperature reading to know about what temperature it starts to actually melt in these different areas along these different boundaries, these different convergent boundaries.
Yeah.
That'd be a really cool experiment.
So for just side note, so for this group project, do we want to like write down our ideas? Is that one of the things that we're supposed to do? Let's write it down.
I was looking at it, and I don't know if we need to write it down, because he said that we're supposed to submit this video.
Right. I feel like each week, I think that the group project seems like it's kind of going to just be like discussions every week. Others, I don't think. I don't know.
Yeah. So I think this is all that we need, is just these discussions, and then as it records, then I'll upload whatever we've recorded.
Okay.
For him to watch.
Perfect. Yeah, I just wanted to make sure, because I was like, oh man, there's so many great ideas. We need to like backtrack and write them all down.
Yeah, we'd have to watch it to write down what we were thinking in that moment.
Yeah.
So I'm looking just to get it.
Yeah.
I looked at lesson 3 group activity. And so next week, what we're going to do is we're each going to bring a mineral to the group meeting. And we'll take turns asking each other questions about the mineral, basically playing 20 questions. And then week 2 instructions, step 2, create a document of how you went about identifying the minerals as a group. Were you successful? Did it take more than 20 questions? 3, submit links to your document and your group's Google Hangout recording in lesson 3. And then lesson 2, the only instructions for this week's group activity: come up with a series of experiments you would like to conduct. Submit your group's experiments by clicking the next button and submitting it through the Dropbox. So I guess maybe you do need to have an idea of what we've talked about. I mean, we've talked about digging holes and putting poles with a cable and seeing which way they're bending and where tension is. We've talked about even just like kind of like as simple as like satellite images, trying to see what's changed, studying earthquakes. We've talked about that. So I think maybe each of us do need to submit something individually like that.
Yeah. It says so. There's like a quiz, and then it says in the quiz, submit the link to your group's recordings and to your group's write-up in the box below. So yeah, you're right. I guess we do have to write something up as well.
But is that everybody on their own writing something, or is that as a collective?
If I remember correctly, I feel like we are all going to have the same one, but I could be wrong.
Yeah, I think we just have to do a group one because it doesn't say like individual recordings. It says to your group's recording to your group's write-up in the box below. So, I mean, worst case scenario, I can just send you all. I could write down all the ideas we have, and then I can like put it on a Google Doc, and then everyone can grab it and submit it.
Okay.
I don't think it needs to be like separate. I don't think it needs to be separate, and there just has to be something there.
Did you guys watch the videos he made for the major projects?
No, I haven't yet.
Maybe.
Like he talked a little bit about this. That's why I'm saying that I think that's what I'm remembering. I feel like he talked just a tiny bit about this, and that we can all use the same document. I guess maybe for next meeting, as we go, one of us will volunteer to just kind of type as we go some of our ideas and stuff. Yeah.
So for next week, though, we all have to pick a mineral and then present it to the group. But what if everybody picks the same mineral?
Well,
how are we supposed to like pick, but then not let anybody know? Like, or I guess we could all pick a letter of the alphabet and find a mineral that's in there. I don't
know. I'd say I think probably we'll do pretty well not picking the same one, but maybe have a backup in mind just in case we have some similar ones. Even then, it's still going to be learning and doing.
So pick up 2 rocks outside and not 1.
Yeah.
True. That's true. Cool. Are we? What time are we at right now?
We're about 50 minutes, I think. Maybe not. Maybe about 40, 45.
Do we want to start listing off our ideas and typing them up? Just get like a quick recap. So,
Ted talked about digging holes and putting poles with a cable.
Yeah.
And seeing where the tension in the cable is, or the way that the holes bend.
The slack of the cable as well.
Mm-hmm. Micah talked about having towers or something on each side of a plate as well, and seeing differences there, measurements there.
But the actual measurements, not like seeing if it gets tight or loosened, but like seeing how much it actually moves and stuff like that.
Yeah, so 2 GPS towers.
Oh, yes.
Okay. So, can you run that idea through me again? I think that's what I missed earlier.
That's okay. So, 2 GPS towers on each side of a
plate boundary.
Right, of plate boundaries and measuring the changes.
Okay.
Or noting the changes. Micah also asked some questions about temperatures and the differences those might make. So Ted had described this one.
But like measuring the melting point?
No.
Yeah.
Right.
Was that what it was? Measuring the melting point? Well, you guys talked about having it on one side of one side of America and the other side of America, and measuring the difference in that.
Yeah.
Well, you were saying we were talking about was it like, is there a difference between melting point on dry land and melting point in the ocean? Is that right?
No. It was what makes it so different, because the Pacific plate, the rift over there, it's moving faster. The Pacific plate moves a lot faster than the Mid-Atlantic ridge.
Yeah.
It's basically looking at the characteristics of each and seeing why the Pacific plate moves so much faster than the Mid-Atlantic ridge.
Yeah.
You would think that all the material is the same at the surface right there, right? Either when it's coming up from the mantle, or the stratosphere, when it's coming up, if everything's melting down and then it's pushing back up to cool off, it should all be the same material. But if one side of the Earth is melting faster than the other, then what's causing it?
Does that make sense, Daniel?
Yeah, but so one of the experiment. So yeah. Oh, sorry. Go ahead.
Oh, you're fine. You're fine. Go ahead.
Oh, so like essentially, the idea, or like the question we're trying to answer, is why does the Pacific plate move so much faster than the Mid-Atlantic ridge? And one of the tests would be, is there like a different melting? Is this still along the same lines of the temperature idea?
Yep.
Like, so we're gonna measure the temperature of each, see like maybe it has something to do with elevation, or I don't know what else.
Yeah, just looking at the characteristics of both.
Mm-hmm.
I would say.
Okay, so looking at the characteristics in general, that might include measuring the temperature, elevation, stuff like that.
Uh-huh.
Yeah. And then Ted also was talking about the satellites, kind of like what they're doing with Venus, and kind of looking at where it was before and where it is now, and kind of the movements and stuff like that.
Yeah, well, and so like, looking at Venus, use the satellites.
Just to compare, images from however this long ago to now, and see what you can see in that. The reading did mention something about Australia is moving northward toward Southern Asia, and so I don't know how much it's moved or anything like that, but if that's something, using satellites, that's something that you would see, is these movements. Not only just like on the continent, but also like how they're moving separately, like with each other, towards each other, that type of thing.
So using satellites to observe the changes in Earth's geography, so that.
Yeah, that's a good.
Mm-hmm. Yep.
And then one other thing we talked about was the earthquakes, and that's kind of, that's something that's already tested, right? Earthquakes and the movement. But you weren't in that discussion, but we just talked a little bit about how the plates don't always just like slide and move like smoothly.
Yeah.
They build up tension. And so say that these plates are moving however much a year, if there's been this tension buildup for so long, once it slides and that tension is broken, that's what creates these movements and the earthquakes and stuff. And so that's something I
wonder if there would be a way of measuring that tension though too. Like, is there like a way of actually figuring out how much tension it takes to create an X size of earthquake, like a 7.2 magnitude, like how much tension would have to be built up in order for that energy to release and cause that to happen.
So I was reading, so I read a couple different articles. I only posted one, but I read a couple different articles, and some people say that that earthquake could have been determined before it happened. But I didn't read a whole lot. So I didn't like go to detail with it. But that's something that is interesting that we could study and find out.
Well, and I've read a lot of, I don't know if any of you have studied any of the articles, but I've read a lot of articles from other students about how, like, stuff on like the Wasatch Fault Line, how scientists have this belief that soon there's going to be a massive earthquake, like maybe one or two or however many, but there's going to be a massive earthquake soon. So, well, part of me is wondering, like, well, how do they know that? Like, how do they know there's going to be a massive earthquake? Like, are they using something to measure it? Is there a way to measure?
It's kind of like the volcano at Yellowstone. Like, oh, there's going to be a mega, like, volcano eruption. You don't know when, but it's going to be soon because it hasn't happened in X amount of years. And you're just like, well, I'm not going to, like, put all my eggs in a basket and believe you because it's like, it still hasn't happened yet. And you have no, like, scientific proof of, like, it's going to happen on this date at this time. And so that's always the funny thing. Like, when you think about those people, it's like, how do you really know exactly what's going to happen?
Right. This has been a good discussion, guys. I've learned a lot.
Yeah.
Daniel, did you get some of those things typed up? And
yeah. So I got the one digging holes and putting poles in each hole. I gotta add that there in order to see how plates will affect the poles, and 2 GPS towers on each side of plate boundaries and measuring the changes between them. And I put this one as a question. So I still need to finish this up. I just realized, why does the plate move so much faster than the mid-Atlantic ridge? Then I'm just going to add by looking at the characteristics of each, and we see the differences, whether it be a matter of temperature, elevation, depth, etc. Or maybe I should add pressure, etc. Right. And then let's see, use the satellites to observe the ongoing process of the development of plate tectonics on Venus. Then the last one I got, use the satellites to observe the changes in Earth's geography. Is there anything else I should add to that?
No, I think you got everything. I think that we had a good discussion today.
Yeah.
Yeah.
Yeah, well, when I was first thinking about it, I'm like, I don't know what kind of experiments to do. Yeah, and I'll share this with everyone, and if you guys want to make it more detailed or anything, then by all means, maybe we can give it an hour, everyone can look over it, and then we can all turn it in.
All right. And for next week's meeting, do we want to try for the same time? Is there something sometimes someone else wants to suggest?
You typically, if it's after 6, I'm available. So.
Okay.
Yeah, after 6 works for me.
All right.
Yeah, me too. It just like next week, the same time will probably be good.
So should we plan more for like 6:30-ish? Would that be, or?
Yeah, I might still be driving just because of the traffic in Salt Lake, so I might just do the same thing that we did tonight, and then.
Right. Was that okay for you? Were you able to focus on driving enough? Felt safe driving?
Yeah, because I mean, it's just, it's not like something like a presentation where I have to watch it. It's just me
just kind of
looking at the road, and it's just stuff by thinking of whatever we're talking about and focus on the road at the same time. So, yeah.
Okay. Yeah.
So this works for me. So I just got home, so I'll take a look at the document if I need to add anything, and then do we want to pick who's going to submit it, or?
So I have to submit the video. Okay. So I can just submit the Google Doc along with it. And so I know the video for getting it all processed through here, it takes at least probably about an hour, about the same time as we did talking.
Okay.
So,
the only thing is that we do show a quiz, an individual quiz for our group activity. So I'm not sure what is in that quiz. I haven't opened it, but we might all need to submit a link in the quiz. I'm not sure.
Okay, I'll submit once I get the video all done. I'll submit you guys. I'll send the link to you guys.
Okay.
Of the video as well, and then we can all just upload it.
Okay, so we're thinking that we're gonna have to upload both the link for the video and also the document that we put together as a group.
Yeah. Speaking of which, can I get your guys' emails? I have Audrey's.
Yes, mine is tsmith4517
4517.
Yeah.
That's sweet. And that worked. And then yours, Micah.
Is Kimura, KIMURA MICH@gmail.com.
Oh, can you repeat it? Sorry, you cut out for a little bit there.
Oh, which part do you have?
Kimura.
Micah, MICAH.
All right, at gmail.com.
Yep.
I might have misspelled that. It's QIMUK.
KIMURA.
Okay. Try that again.
And I'll type it in the group chat thing as well.
Let me know if I get it. Okay, I got it.
Okay.
All right, cool. We have the group text, so if we have any questions or anything, we can chat it up there. And
Chat it up.
So,
it sounds like Ted's going to be our savior if we really need to know anything about this class.
I know. Yeah. Great.
Yeah.
All right.
I kind of feel ashamed because my dad owns a rock quarry, so I should know something about geology. But, maybe that's why I'm taking this class. I need to learn something about geology.
Learn about the family business.
Yep.
Yeah.
All right. Well,
that's why.
night,
yeah.
guys.
Anyways.
Bye.
Night.
Alrighty.